Hi, everybody. This is a lesson that will help you to review what is a mole, how you can relate that to other units of measure for elements like mass. If you're wanting to convert from moles into mass or particles, which we learned was Avogadro's number. Okay. You're going to learn what you call the particles for an element, an ionic or a molecular compound. And we're going to practice a few calculations and learn how to give those answers with labels and the correct significant figures. So let's get started. You learned the other day that a mole is a counting quantity just like we would use maybe like a dozen. Whereas a dozen is always 12 of something, a mole is always 6.02 times 10 to the 23rd of something. If we have an element, then we know that we have 6.02 times 10 to the 23rd atoms, because the particles of an element are called atoms. If we have a compound, it kind of depends on which type of bond is in the compound. If you have a molecular compound that's held together with covalent bonding, remember that's where the atoms are sharing the electrons. Then a mole of a compound is 6.02 times 10 to the 23rd molecules of that compound. Like, for example, a mole of water is 6.02 times 10 to the 23rd molecules of water. A mole of carbon dioxide is 6.02 times 10 to the 23rd molecules of carbon dioxide, etc. If you have an ionic compound where it's held together by ionic bonds, that would be where you have the transfer of electrons. You have a positive and a negative ion. Because they don't form individual molecules, but instead form big network crystals, what we do, remember, is refer to the simplest ratio of ions within that compound. So we'd say we have 6.02 times 10 to the 23rd formula units for those, because the simplest ratio of ions within the network is called the formula unit. So that would be what we want to call the particles. If I had a mole of eggs, each individual would be an egg. But this is, if you have a mole of elements, you call the individuals atoms. If you have a mole of a molecular compound, the individual particles are called molecules. And if you have a mole of an ionic compound, then the individual particles are called a formula unit. So you'll see me use, that different vocabulary. Remember that 6.02 times 10 to the 23rd is given that special name of Avogadro's number. Okay, so what can we do with that number? Well, just like you can take, like, for example, and say, I have 3 dozen eggs. How many eggs do I have? Well, 3 times 12 eggs per dozen is 36 eggs. We can use this number, this equality, to do conversions in the factor label system that we learned earlier in the year. Here's an example. What if our question said, how many atoms are in 2.5 moles of barium? Remember that you start with the given number, 2.5 moles, okay? And you set up a conversion factor. You have to have where the top and the bottom of the conversion factor are equal. That's where this comes into play, because these two are equal. But we would put the 1 mole of barium on the bottom so that our unit would divide out. And we would put the 6.02 times 10 to the 23rd, and I'm going to call them atoms because barium's an element, on the top. Now, you can see here that when we multiply by 6.02 times 10 to the 23rd and we divide by 1 mole, our moles of barium units will divide out. And then that means that the unit on our answer is going to be atoms of barium. You would need to plug this in your calculator, depending on which type of calculator you have. You would either want to, remember, use that E button. Instead, like, you don't hit times 10, you enter 6.02 and then E23. Or sometimes it's an EE button. If you don't have that, you might have to put parentheses around numbers that you enter if you are going to do the times 10 caret 23. And so you'll have to try on your calculator and make sure you get this. When I plug it into my calculator, I get 1.51 times 10 to the 24th, and that is atoms of barium. Okay. Now I kept 3 significant figures because my original number had 3 significant figures. I labeled not only what are the particles called, but what kind of particles are they. So let's try another one. Okay. How many moles are represented by 5.0 times 10 to the 22 water molecules? So you always start with the number that you're given. Okay. Now this is molecules. Oh, that's that little random. Every once in a while I get that. And I was going to say it's kind of, oops, not the pen, not the highlighter. Okay. Okay, so molecules of water. And again, we can set up a conversion factor. We have to put the molecules on the bottom this time so that the units will divide out. And molecules is what we call the particles of a covalent compound. So we're going to put Avogadro's number of molecules on the bottom. And once again, there's my little random line. Must be something going on here. I keep doing that. And we would put the 1 mole of water on the top. Man, that's going to get me today. So you can see that again, the top and the bottom of my factor are equal, that the molecules of water would divide out. And be very careful when you're entering it in your calculator this time. I'm sure that you either need to use the EE button or you need to put this in parentheses or you will get the wrong answer. It is 0.083. You don't have to have that 0 in front of the decimal, but I always like to include it. Moles of water. And that would be your final answer. So make sure you can get those two before you move on. You can always pause the video and practice a little bit and make sure that you get those answers. Now, let's say I want to know how many atoms of copper are in a 1970s penny. Okay, we know that a mole is 6.02 times 10 to the 23rd atoms of any element, and copper is an element. And for any element, here's some new info. A mole is equal to the atomic mass of that element in grams per mole, 1 mole. So for copper, we know that a mole of copper is 64 grams. Where do we get the 64? Go to the periodic table, look up the atomic mass for copper. That number has a double meaning, okay? You round it off to the whole number. That's how many atomic mass units are in a single atom of copper. But if you had a mole's worth of atoms, it will weigh that many grams. So you can see that little double meaning of the atomic mass. So this is going to come in handy. We know these two things. And the mole is just sort of that central unit. We know how to interconvert between the moles and the atoms. That's using Avogadro's number. We know how to interconvert between the mole and the grams, because that's using the atomic mass from the periodic table. And so if we want to answer that question of, whoops, I think I should put my writing down a little further. Sorry about that. But if we want to answer this question then, where it says, if a penny has a mass of 2.35 grams, how many atoms of copper in the penny? Remember, the mole is, we know how to interconvert between mole and gram. Oh, there's that crazy line again. It's just not my day with that. Sometimes I really don't do that a lot, and other times I do. And we know how to interconvert using Avogadro's number between atoms and moles. So you always take the number that you're given and you know that you start with. Okay. So here we have 2.35 grams of copper. And I literally took a penny and I weighed it, okay, to see what the mass was on our balance. Now, from grams, I can convert to moles. And then from moles, I can convert to atoms. So going from grams of copper to moles of copper, I have this first one, 1 mole is equal to 64 grams. Now you got to make sure the top and the bottom of your number, or of your factor, are equal. Like I would never say 12 dozen is equal to 1 egg. I got to be careful. I know it's 1 dozen is equal to 12 eggs. So here it's 1 mole is equal to 64 grams. I would never say 24 hours is, or I would say 24 hours is equal to a day. I would never say 24 days is equal to an hour. Do you see that? So you got to make sure you get the right number with the right label. The number from the periodic table goes with the grams. The 1 goes with the mole. Okay. So does that make sense, everybody? And this 6 is a mess. So I'll fix that. Okay. So now that allowed us to convert from grams into moles, but now we need to do 2 steps. We need to convert from moles into atoms. So we're going to add another step. Since the moles is on the top over here, we will put it on the bottom over here, and we will convert from moles to atoms. We know that it's 6.02 times 10. You know what? I'm going to erase just because I just did not leave myself enough room up there. And I even know better. So see, that happens. 6.02 times 10 to the 23rd atoms of copper is the same as a mole. That's this conversion. And again, we know that it's 12 eggs in a dozen, not 12 dozen in an egg. So we have to put the Avogadro's number with the atoms, and then we have to put the 1 with the mole. Do you see that? Okay. Now, what this has allowed us to do, though, okay, is when we go through here, we will multiply by 1 mole and divide by 64 grams. So now the grams of copper will divide out. And then we will multiply by Avogadro's number of atoms and divide by 1 mole. Then the moles of copper will divide out. And our only label will be atoms of copper. And when I do that, I took 2.35 times 1, divide by 64, times Avogadro's number, divide by 1. I got 2.21 times 10 to the 22nd, and that is atoms of copper. Now, this is something that I would never be able to individually count the atoms of copper in a penny. First of all, there's just way too many of them to count. And second of all, they are way too small for me to even see them to count them, and they're all stuck together. But by simply plopping my penny on the balance, getting the mass, and knowing these 2 conversions, I was able to figure out how many individual atoms make up that penny. And it's 2.21 times 10 to the 22. Let's try 2 more, I think, sample problems that I have. What is the mass of 1.5 times 10 to the 24th atoms of gold? So remember, we know how to interconvert atoms and moles, and we know how to interconvert moles and mass. We need to do both steps in this problem because we're starting with a number in atoms. We have to convert it to moles, and we're looking for an answer in grams because the label for mass is grams. So then we have to go from moles to grams. We need 2 steps. So we start with the number that we're given. Notice this one only has 2 sig figs. So I'm only going to keep 2 sig figs in my answer at the very end. Okay. So we start with our atoms of gold, and gold is AU. Okay. Oh, some people put a line under that. I don't. Some people like to put a line under it and put a 1. So I'll let it there since I did that, but I don't usually do that. So we need to convert from atoms of gold to moles, because that's our first step right here, atoms to moles. There's that little random line again. Gosh darn it. We know that a mole of gold is Avogadro's number of atoms. Notice that our units are going to divide out because you divide by numbers that are on the bottom. And then we can keep going because we don't want an answer in moles of gold. We want an answer in mass. So we're going to keep going. We know that a mole of gold, okay, is equal to 197 grams. How do I know that? I looked on the periodic table. I found the element Au, which is gold, and I looked at the atomic mass that's listed for it and rounded it to the whole number. Again, because we divide by what's on the bottom, moles Au divided by moles Au will cancel out. To get our answer, we need to plug into our calculator 1.5 times 10 to the 24th, divide by the 6.02 times 10 to the 23rd, and multiply by 197. And I got 490, then it's like 0.8, blah, blah, it's like a whole bunch of numbers. But I'm going to round that to 2 sig figs, and my label is grams of gold. As long as I don't put a decimal on the end of this, that zero is not significant. Remember, trailing zeros are not significant unless there is a decimal. So this has 2 sig figs, and this is a good answer. Let's do one more problem, and then we'll wrap this up, and you can practice some problems on your own. What is the mass of 1.65 moles of lead? Remember, lead is an element. We know how to convert atoms to moles, and we know how to convert moles to grams. In this problem, we are starting, okay, with moles of lead. 1.65 moles of lead. We're right here. We're starting with moles, and we need to find mass. We just need one step. We don't need anything to do with Avogadro's number in this problem. We don't have to convert it into atoms. We don't have to convert atoms to moles. We're moles, and we know how to convert from moles to grams directly. We know that a mole of lead is 207 grams. Where did I get that number? I looked on the periodic table. I found element Pb, and its atomic mass was 207. I rounded it to the whole number. So there's 207 grams in a single mole of lead. Okay? So now I can divide out my units, because moles of lead divided by moles of lead. I can plug this in my calculator, 1.65 times 207, and I got 342 grams of lead for my answer. So when you're doing these, labels are really important. Like, know what unit you're starting with so that you know where you are in this. Know what unit you're looking for so that you know how many steps you need to do to get there. And sometimes you can actually skip one of the steps, and it's a nice, easier problem. So we know that a mole is 6.02 times 10 to the 23rd particles. We know that that number is Avogadro's number, and that we can convert, from moles to molar mass, the molar mass being that mass on the periodic table. We know how to interconvert moles, mass, and particles for the elements. We just did a few sample problems. We know that for an element, the particles are called atoms. For an ionic compound, they are formula units. And for a molecular compound, they are molecules. And we practice putting labels and giving our answers with the correct number of significant figures. So go practice the problems and see me if you need some help. Good luck.